back to dilemma's concepts. It says find the area bounded between y is equal to 3x squared minus 10x and x equal 1, x equal 3. So here's a quick diagram representing the idea. What we really want to find is that we want to find the area bounded between right here and here. So we want to know this, right? There's one thing that we want to bear in mind, though. We want to bear in mind that whenever we're taking the integral to find the area, the result that we're going to get, right, is highly depending on whether or not the part of the curve that we're dealing with is underneath the x-axis or above it. So in this case, it is underneath the x-axis, which means that we're expecting a negative number. But remember, area cannot be negative. So when we do get a negative number, we're going to have to take the positive of it based on the context of what we're dealing with, right? So in order to do this, we're going to take the definite integral of 3x squared minus 10x. We're going to take the definite integral of that, and we're going to take it from 1 to 3. So our lower limit is 1, our upper limit is 3. So what we're going to do now is just to integrate this quickly. Remember the idea behind integration. So this is going to actually be 3x to the third over 3 minus 10x squared over 2 plus c, but we're not going to be having any c, right? And then this that we have here is from 1 to 3, right? Basically, we want to simplify this though. So when this is simplified, we're actually getting x to the third minus 5x squared from 1 to 3. This is what we have when everything is simplified. So what we're going to do now is to plug in the values. So remember, we're expecting to get a negative number, but that doesn't mean that the area is negative. So let us drop it in. So we're going to substitute that upper limit now, which is 3. So it's going to be 3 raised to the third minus 5 times 3 squared. And we're going to take from that 1 raised to the third minus 5 times 1 raised to the second power. All right, so let us see what we actually have. So what we have here is 3 actually have here is 27. 3 raised to the third is 27. And this is going to be 9. This is going to be minus 45. And then in here, we actually have 1. 1 to the third is still 1. And then we have minus 5, right? So let's have a negative 18 coming right here. And then in here, this is going to give us negative 4. So this is actually negative 4, and then a negative is here, so it's actually plus 4. So this is giving me negative 14. What we want to do is to bear in mind, because we're dealing with area, it's not going to be negative. So this negative value here is just an indication that this part of the curve is underneath the x-axis. So the area that we're actually dealing with is actually the positive of that, which is 14 square units. So that is actually the area right there, 14 square units. Let us take a look at question 2. Find the area bounded between y is equal to negative 2x squared plus 8x and x equal 2 and x equal 4. So basically, this is the curve that is we're dealing with. The interval that we're dealing with, though, is positive 2 and 4 here. So we want to find the area here all the way up. We want to find this area here, here. This is what we really want to find. Now, interestingly, this one is above the x-axis. So definitely, I am expecting to get a positive value here, all right, because it's above the x-axis. So let us deal with this. We're going to take the integral from 2 to 4 of negative 2x squared plus 8x, right? We're going to take the integral of that. So let us apply our integration rule. So we're going to have negative 2x to the third over 3 plus 8x squared over 2, and we're moving from 2 to 4. I'm going to simplify this. So basically, we have negative 2/3 x to the third plus 4x squared. We're moving from 2 to 4. Let us plug in our limits now. Let's plug in our limits. So what we're dealing with here is that we're going to have -2 over 3. X is going to be 4 raised to the third plus 4. X is 4 square. Subtract -2 over 3. X, which is 2, to the third plus 4x, which is 2 square, and we're done. So let us try to simplify this right now. 4 raised to the third power, that's going to give us 64 times -2. It's negative, all right, so we have -128 over 3 here. So let us look. 16 4 4, so we want to square that. So 16 times 4, that's going to give us positive 64 right here. And let's go inside this bracket here. So what we have in here, 2 to the third, that's 8. 2 is -16, so I'm having -16 over 3 here. 2 2 is 4, right? And 4 4s will give me 16 right here. So this is what we have. So let us keep breaking this down and let's see what we really have. So this is about -42. This is -42 and 2/3, all right, plus 64. So let me add 64 to that, right? So plus 64, I'm just breaking this down just a little bit, minus what we have in here. All right, let's break this down. All right, so this is basically -5 and 1/3 plus 16. All right, let's simplify it. If I have -42 plus 64, that's going to give me 20. It's going to give me 21 and a third, right? So that's going to give me 21 and a third right there. Here, this is going to give me 10 and 2/3. So it's going to be minus 10 and 2/3 because -5 and a third with the 16 is going to give me -10 and 2/3, right? So if we do put this together, we're going to end up with positive 10.6666, or it's 10 and 2/3. As we see that we were expecting a positive response. So the area here, this here, the area of this right here, is actually, we're suggesting that this area covered is 10 and 2/3 units squared, right? So that's what we have in that case right there. Let us take a look at the last one now. All right. In this case, what we're doing is we're looking on an idea when we have the area above and below the x-axis. For example, we want to take we want to find the area bounded between 2x to the third plus 3x squared minus 5x and x minus 1, x equal 1. So basically, let me mark off the spots that we're dealing with. We are actually dealing with this. And let us do a quick explanation here. This is my -1. This is my 1. All right. So we really want to find it right here. We want to find it here. But you notice that this part is above because this is very crucial. So this part is above the x-axis, right? And then when we take a look, we're realizing that this other part here is beneath the x-axis at 1. Now, if we actually do this in one go, what happen is this negative part that is under here will be subtracted from the area here, and that's not what we want. So what we're going to have to do, we're going to split it, and we're going to take from 0, we're going to take from -1 to 0, and then we're going to take from 0 to 1. And so we're going to split it, and then we add the ideas, because remember, in the part in blue, we will be getting a negative response, but we're going to take the positive number from that because we're dealing with error, and we're going to add the idea. So let us put it together. All right, let us, so first part, the part in red, which is this part right here. We're going to take the definite integral of 2x to the third plus 3x squared minus 5x dx. And we're taking that from -1. So we move from -1 to 0. As we say, this part is the part above the x-axis, right? So let us do a quick integration of this part. So it's going to actually be 2x raised to the 4 over 4 plus 3x raised to the third over 3 minus 5x to the second over 2. All right, so that's what we have. We're moving from -1 to 0. So technically, we could cancel. If we cancel down, we're going to end up with x to the fourth over 2, because this cancel right here. And then we're going to have plus x to the third, because this cancel right here, minus 5 over 2x squared. And remember, we're moving from -1 up to 0. All right, let us do a quick substitution. No. So when 0 is in, we're actually going to have 0 raised to the fourth over 2 plus 0 to the third minus 5 over 2, 0 squared. We're going to subtract x, which is going to be -1 raised to the fourth over 2 plus -1 raised to the third minus 5 over 2, -1 to the second power. Because all of these that we have here, 0 is at the numerator, that's 0, this is 0, this is 0. So we're actually getting a 0 for that part. So all of that is 0. Let us focus on the back part. Remember now there's a negative out here. So let us break this down. -1 to the power of 4 is actually +1. So this is a half. -1 to the power of 3, this is actually a -1. And then right here, -1 squared, it is still positive. And then, so we're actually having +5 over 2. Now, if we break this down, basically, what I could do is just to distribute this -1 inside. So this is -1/2, +1, +5 over 2. And when we break this down, 5, so this is basically 3. All right. So we actually have 3.5. This part comes to 3.5 minus a half. So this is 3. And we were expecting to get a positive number. Why? Because it is this red part, which is above the x-axis. Now, so remember now, we're going to keep this in mind. Let us now take a look at the other part, right? Now, remember, we're dealing with the part in blue right here. So the part in blue is underneath the x-axis. So we're definitely expecting to get a negative value, but we're going to fix it up. So we're going to take the definite integral. We're going to take it from 0 to 1. So now we're moving from 0 to 1 right there, right? And we're taking it off what? What do we have? So we have 2x to the third. So 2x to the third plus 3x squared minus 5x, right? Dx. So now let's finalize this. So over 2, and this one came up to plus x to the third, right? Minus 5 over 2x squared. Remember, that's what we actually got already because we did it. So we're moving here from 0 to 1, right? So let us just plug these in now, right? So this is going to actually equal to 1 to the fourth over 2, right? Plus 1 to the third minus 5 over 2, 1 square. And then we're going to subtract 0 to the fourth over 2 plus x plus 0 to the third minus 5 over 2, 0 square. We're doing that. So when we take a look at this part though, 0, 0, 0, this is a 0. So all we got to do is to work out the front part. So 1 to the fourth is 1 over 2 plus 1 to the third is 1. And this is going to give me minus 5 over 2. If you check this out, what this is actually, this is 1.5, and this is -2.5. So this is 1 and a half right there minus 2.5. So as you could see, I'm getting a -1. We were expecting to get a negative value because we saw definitely that this part of the curve that we're dealing with is actually beneath the x-axis. Now, how are we going to put it together? Let's go back for our responses. Now, the area that we're looking for, remember that this one was actually 3, right? We found this to be -1, but we do understand that -1 is just telling us that it is under the x-axis. But in terms of a value for the area, you're going to have to use positive. So we're going to combine them. So it's going to be 3 plus 1, and this is going to give us an area of 4 units squared. So there it is, right? Thank you for watching Daily Math Concepts, and I hope this makes sense to you. See you next time. Bye-bye.